All right, let's dive right into this explainer. We are tracking the thrilling play-by-play journey of Starship version 3's fully redesigned mega rocket. If you've been following the pursuit of rapid, reliable space reusability, you already know just how massive this specific test flight was. So we're going to break down the exact sequence of events step by step from Pad 2 all the way to the Indian Ocean. Here is our flight plan. We'll follow the timeline chronologically, starting with countdown and liftoff, moving into the crucible of hot staging and engine performance, checking out the Space Coast and payloads, riding through re-entry and splashdown, and wrapping up with what all of this means for our multiplanetary future. Section 1. Countdown and liftoff, overcoming the hold. Our journey begins on the newly redesigned Pad 2. Now, to really appreciate the triumph of this liftoff, you've got to look at what happened during the previous day's wet dress rehearsal. At T-minus 42 seconds, a hydraulic pin on the pad tower's quick disconnect arm triggered a hold. It essentially got into a tug-of-war with the tower's systems. But the rapid iteration here is just incredible. The engineering team executed heroic hardware and software changes overnight, literally welding in new hardware to cut down arm motion and tweaking the software logic. Because of that hustle, the next day, the countdown proceeded flawlessly past the T-minus 10-second point of no return, right down to zero. At zero, all 33 brand new Raptor 3 engines on that super heavy booster ignited simultaneously. Picture this, a towering 407-foot vehicle, which is actually a bit taller than version 2, by the way, getting shoved into the sky by over 18 million pounds of thrust. The launch pad modifications, including the new bidirectional flame diverter, held up perfectly as this absolute beast cleared the tower. Moving on to Section 2, hot staging and engine performance, the crucible. Okay, now we're entering what's arguably the most complex and critical aerodynamic phase of the whole flight, the hot staging sequence. This is a seamlessly integrated maneuver where the upper stage, the ship, powers away while it's still attached to the booster to maintain its massive momentum. First, the booster shuts down 28 of its engines, leaving just 5 sustainer engines firing. Then, the ship's 6 Raptor engines ignite directly into the top of the booster. All that insane force is offset by internal tank pressure and non-structural steel shielding. And it worked flawlessly, resulting in a perfectly successful separation and a directional flip for the booster. But, a test flight is literally about pushing the hardware to its absolute limits, finding the edges of the envelope. And that's exactly what happened next. The booster experienced an early shutdown during its planned boost-back burn, so it didn't complete that specific phase, ultimately executing a controlled landing in the Gulf. Meanwhile, the ship faced its own uphill battle. On its way to space, it actually lost one of its Raptor vacuum engines, or RVACs. So, how did the ship handle losing an engine? Beautifully. This right here is the magic of engine-out capability. The system's built-in resilience immediately kicked in. The remaining 5 engines automatically gimbaled, meaning they physically steered, to compensate for the offset thrust, and they just burned a little bit longer to make up the difference. Thanks to this incredible synergy between the hardware and the software, Starship achieved a successful orbital insertion anyway. Which brings us to Section 3, Space Coast and Payloads, the supercharged Pez dispenser. All right, we are in space. Orbit achieved. Now the upgraded ship gets to show off its new supercharged Pez dispenser mechanism. This completely redesigned system pushes payloads out significantly faster than previous iterations. In total, the Bay deployed 22 items, 20 Starlink V3 mass simulators, which are roughly the same size as the massive future internet satellites, and 2 very special tech demo satellites affectionately nicknamed Dodger Dogs. What is super fascinating to me are these Dodger Dogs. Once deployed, these modified satellites performed an absolutely stunning tech demo. They turned on bright white flashlights to visually inspect Starship's heat shield in the pitch-black vacuum of space. Capturing this real-time video before re-entry provides vital, unprecedented data on tile health. And as we know, that data is a massive key for future rapid reusability. Section 4. Re-entry and splashdown, surviving the plasma. After a nice, quiet orbital sunset coast over the Indian Ocean, Starship had to face the brutal physics of re-entry. Slamming into the Earth's atmosphere at roughly 8 kilometers per second, guys, that is more than 5 times the speed of sound. The ship was instantly wrapped in a superheated plasma field. Now, typically, this intense plasma totally distorts communication frequencies and causes a blackout, but because Starship is equipped with Starlink terminals, it managed to punch its telemetry and live high-definition video right through the plasma field. Engineers were literally watching the thermal tiles do their work in real time. This timeline tracks that fiery descent. Once past peak heating, temperatures finally began to drop, but the aerodynamic stress was just ramping up. At Mach 7, the engineering team threw in a wild card, a maneuver they call a flap slap. Because they skipped an in-space engine relight, they had extra propellant in the header tanks, making the nose heavy. So, they intentionally pitched the vehicle up to put extreme structural stress on those aft flaps, just to find the system's absolute limits. And you know what? The flaps held beautifully. Passing into subsonic speeds, the ship executed its iconic belly flip maneuver to get vertical, perfectly setting up for the finale roughly 65 minutes after liftoff. Even after taking that immense beating in the atmosphere, the ship had one last test. The standard intended landing burn utilizes 3 sea-level Raptor engines, but for this test, they aimed to pull it off with just 2. And those 2 sea-level engines roared to life perfectly, righting the ship and resulting in an incredibly precise, on-target, soft splashdown right in the water. And finally, Section 5, the multiplanetary future, why we test like we fly. At the end of the day, all of these incredibly hyper-technical milestones boil down to one massive, overarching goal. As the engineering team put it during the mission, we launch to learn, and we test like we fly. Gathering this violent reentry data, capturing video of the heat shield in the vacuum of space, and proving engine-out capabilities under maximum dynamic pressure, that is exactly what's required to make rapid reusability a reliable reality. You simply don't get there by playing it safe on paper. You get there by bending the hardware in the real world. Because a fully functioning Starship V3 is literally the backbone for our future in space. In the near term, sure, we're talking about deploying larger Starlink V3 satellites for a massive global bandwidth jump. But looking further out, this architecture enables high-bandwidth lunar surface laser connectivity, the construction of a permanent moon base for the Artemis program, and ultimately making life multiplanetary with actual settlements on Mars. So I'll leave you with this to ponder. We just watched Starship V3 survive its first full flight. It endured the crucible of hot staging, pushed through an engine failure, and braved a fiery Mach 23 re-entry to prove its extreme resilience. With all those engineering feats now in the books, how fast is our multiplanetary future actually approaching? Thanks for joining me on this explainer today. Keep your eyes on the skies and never stop learning.